Hello everyone. In today's section, we are going to discuss about half subtractor. As a lecture series on digital electronics, we'll be discussing about half subtractor today. So as we have discussed about adders, half adders and full adders, we need subtractors also in an ALU. Arithmetic operations include basically addition and subtraction. So we have subtractors in ALU. This is a CPU or a processor, and these are the components inside a processor. And one of the component is ALU, which need the subtractor. And this is the logical symbol of ALU with inputs and outputs. Subtractor is basically used to make arithmetical and logical operations. Two types of subtractors are there, half subtractor and full subtractor. So in this section, we are going to discuss about half subtractors. Before entering, let us see why do we need subtractors? What are the other places we require subtractors? Half subtractor is used to reduce the force of audio or radio signal. When we need to reduce the force of the signals, we'll be using subtractors. It can be used in amplifiers to reduce sound distortions. If you have any distortions, subtractors can be used. Then it is used in ALU as we have discussed. It can be used to increase and decrease operators and also calculate the address when it comes to the memory computer architecture. Now, what is half subtractor? It is a combinational logic circuit which is designed to subtract two binary digits. Again, combinational circuit is wherein the present output depends only on the present input. It do not have a feedback. It has two input terminals, and if you see here, half subtractor is similar to half adder where we have two input terminals and two output terminals. Here the two output terminals will be difference and borrow. This is the design procedure of half adder wherein first we will be drawing the truth table, that is the condition different conditions between relationship between the input and the output. Then we'll be drawing a k-map. Then from the k-map boolean expressions has to be arrived, and then we'll be drawing a circuit. So this is half subtractor AB. We have two inputs and two outputs. So when the input is 0 0, obviously the difference and borrow will be 0, as well as when the input is 1 and 1, the difference will be again 0 and borrow will be 0. When it comes to 0 and 1, the difference will be 1 and then the borrow will be 1 because we are subtracting 1 from 0. Right? So we need to borrow, and so we'll be having difference 1 and borrow 1. If it is 1 and 0, it's like a normal subtraction. The difference will be 1 and no borrow will be there. Then this is the K-map for half subtractors. So here, see for this condition, that is when A equal to 0 and B equal to 1, the difference is 1. And when A equal to 1 and B equal to 0, the difference is 1. So A is equal to 0 and B equal to 1, this is the cell where the difference is 1. And when A equal to 1 and B equal to 0, this is the cell where where the difference is 1. So these are the two ones which is being marked here. And here we have only 1, 1 when A is equal to 0 and B equal to 1. So when A is equal to 0 and B equal to 1, this is the cell corresponding to that, and we have mentioned it here. Now we have to group it. Here grouping is not possible, so only single ones can be grouped. So after grouping, if we write the common terms for this, it is A dash and B. For this, it is A and B dash, which is an XOR gate. So it has been written here. And for this, if we consider the common term, this row A dash is common and B is common. So these are the two Boolean expressions which we have arrived at. And from the Boolean expression, we have directly draw the circuit diagram. Here we have an XOR gate, inputs are A and B, so we have marked it. Then we have a borrow, which is not version of A, complemented version of A and B. So A through a NOT gate. Complemented version is being given to an AND gate, and B is directly given to achieve the borrow. So this is free assessment, and thank you so much.